Imagine stepping into a quiet meadow on a warm afternoon. The air hums softly as bees move with purpose, disappearing into a hive that, at first glance, seems unremarkable. But inside that hive lies one of the most extraordinary architectural achievements in nature. In darkness and silence, without rulers, blueprints, or calculations, bees construct perfect, repeating structures that have fascinated scientists and thinkers for centuries. Their honeycombs are not just storage units for honey. They are masterpieces of efficiency, strength, and design. What makes this even more compelling is that humans, across thousands of years, have independently discovered many of the same principles. If we look closely at a honeycomb, we notice a striking pattern. Every cell is a hexagon. This shape is not chosen for beauty, but for efficiency. It represents the solution to what mathematicians call the Honeycomb Conjecture, the problem of dividing a surface into equal areas using the least amount of material. Among all possible shapes, the hexagon achieves a perfect balance. Circles leave unused gaps. Squares are less efficient in distributing force, but hexagons fill space completely while maintaining strength and minimizing material use. Bees do not solve equations. They do not study geometry. Yet, through instinct and natural processes, they arrive at the same solution that humans took centuries to understand. But geometry is only part of the story. Bees build using wax produced by their own bodies. At first, the cells are not perfect hexagons. They begin closer to circular forms. As the temperature inside the hive rises, the wax softens. Surface tension begins to act on the material, gently reshaping the cells until they settle into hexagonal patterns. This transformation reflects deep physical principles. The structure is not forced into shape. It emerges naturally, guided by the laws of energy and efficiency. Long before modern science could explain these processes, human civilizations were already exploring similar ideas. In ancient Greece, architects pursued harmony through proportion and geometry. Their buildings reflected a belief that beauty and function were inseparable. While they did not directly imitate bees, they followed the same underlying logic, that the best structures are those where efficiency and form align. Centuries later, in medieval Europe, Gothic cathedrals rose toward the sky. Structures like Notre Dame in Paris used repeating elements, arches, and vaults to distribute weight in remarkably efficient ways. These buildings were not only visually stunning, but structurally optimized, much like a honeycomb. Across the world, traditional settlements often reveal similar patterns. In many cultures, homes are built closely together, forming dense, interconnected layouts. These arrangements reduce wasted space and create systems where each part supports the whole. In the 20th century, the connection between human design and natural structures became more explicit. Architects and engineers began to study nature directly, not just for inspiration, but for solutions. Figures like Buckminster Fuller explored how to create structures that were both lightweight and strong. His work echoed the same principles found in honeycombs, distributing forces efficiently through repeating patterns. Today, honeycomb structures are used in fields ranging from aerospace engineering to modern architecture. They appear in airplane components, building materials, and innovative design systems. One striking example is the Beijing National Aquatics Center, often called the water cube. Its structure is inspired by natural cellular forms, showing how ideas from biology can be transformed into large-scale human creations. At the same time, a new kind of design is emerging, one that brings human thinking even closer to nature. Bees build without a central planner. No single bee controls the hive. Instead, complex structures emerge from simple actions repeated by many individuals. This phenomenon is known as swarm intelligence. Modern designers are now using similar approaches. With parametric design and generative algorithms, architects define conditions such as materials, forces, and environmental constraints. Then, instead of drawing a final form, they allow it to develop organically. In a sense, buildings are no longer just designed. They are grown, This shift is especially important in a world facing environmental challenges. Bees build with minimal waste, using only what they need, creating structures that are both efficient and sustainable. These same goals are now at the center of modern architecture. By studying natural systems, designers are learning how to create buildings that consume less energy, adapt to their surroundings, and make better use of materials. Perhaps the most profound difference between bees and humans lies in awareness. Bees build through instinct and collective behavior. Humans build through knowledge, calculation, and intention. And yet, at the cutting edge of design, human methods are beginning to resemble natural processes once again. This raises an intriguing possibility. Are we truly inventing something new? Or are we rediscovering patterns that have existed in nature all along? Bees have never studied engineering. They have never written theories or drawn plans. Yet their hives embody principles of geometry, physics, and efficiency at the highest level. As we look toward the future, their example offers more than inspiration. It offers guidance. Perhaps the most advanced architecture will not be imposed on the world, but will emerge from it, shaped by the same forces that have guided bees for millions of years. And in that sense, the first architects were not human at all. Bees have never written architectural theory, but in wax and symmetry, they may have authored its oldest chapter.